Hello everybody. Today I'm going to explain and demonstrate to you the acoustical phenomenon of beats. So what are beats? When two sound waves of close frequency are being played together, the human hearer perceives a sound of single frequency fluctuating in intensity. So why are beats even formed? To understand that, let's consider two sine waves, or two pure tones of frequencies 500 Hz and 510 Hz. Now if you observe here, one of the wave has a shorter wavelength and the other has a larger wavelength. Now you might know the frequency and wavelength relationship for sound waves. Well, frequency is inversely proportional to its wavelength because speed of sound in air is a constant around 343 meter per second. So considering this relation, we can see that the blue wave has a larger wavelength compared to the red wave, which means the blue wave is a low frequency wave. Around 500 Hertz, and this wave is around 510 Hertz. So what happens when these two waves are being played together? It forms a beat. But how, what is the process of this beating? So if you look closely here, these two waves are interacting, meaning they're going to interfere with respect to each other, and the interference can be a constructive interference or destructive interference, and this totally depends on the phase difference between these two waves. Now, if you look closely here, this is a crest for a wave and this is a trough. So the crest of both waves are coinciding with respect to each other, meaning the phase difference is zero, and hence they're going to add up or they're going to interfere constructively. But as we move forward in time, if you can see here, these waves are no longer in phase with respect to each other. I mean, the difference is increasing, and it keeps increasing, and at one point, the phase difference is 180. Meaning these two waves are exactly opposite in phase and they're going to cancel out each other. And this is a point where they interfere destructively, meaning they're going to cancel out each other completely. And then after some time, as we move forward in time, again the phase difference keeps decreasing, and then at one point it becomes zero. So they again interfere constructively. And then again, as we move forward in time, they interfere destructively. So this alternating pattern of constructive and destructive interference keeps going on because of the difference in frequencies. And the resulting pattern looks something like this. This is the point where both waves have interfered constructively, and this is the point where they have interfered destructively. And this pattern keeps going on and on. Now the alternating, constructive and destructive interference, results in a soft and loud sound, alternatively, which is, gives a sensation of beating or beats. Now, the number of chunks, meaning from destructive to destructive, the number of chunks being played in a second is the beat frequency. And the beat frequency is the difference between these two frequencies, the absolute difference. Why absolute? Because, you can have one beat frequency for two sets of frequencies. For example, here I've considered 500 Hertz and 510 Hertz. Now that gives me a beat frequency of 10 Hertz. But you can have a beat frequency of 10 Hertz for 490 and 500 Hertz as well. And there is a fun fact. A human hearer can register beats or beating effect when the ratio of frequencies is less than 7 by 6. In this case, it's 510 by 500. Well, we're way less than 7 by 6. Alright, now I'm going to demonstrate to you, how does beating even sound by using software Audacity. Hey there, this is Audacity, and I'm going to use it to demonstrate, the acoustical phenomenon of beats. So the first wave is 500 Hertz, and the second wave is 510 Hertz, and I'm going to play them together to give the beating effect. If you notice clearly, you can see that those two waves are alternating between, constructive interference and destructive interference. Alright, another important thing to note down here is the amplitude level. Now if you notice here, I've kept the amplitude levels to be same. Now what happens if I increase the amplitude level? Well, a little bit of increase doesn't create a big of a problem, but if it increased to a very great extent, one frequency will start masking the other frequency and you will no longer hear beats. Let's try that. And I'm going to increase this level. So I hope now you don't hear beats, because this frequency is so loud that it's actually masking the other frequency. Let's stop it. Alright. Thank you for watching this video. I hope you enjoyed it. Have a great day.